Prompt engineering basically is the way you interrogate the model, providing him some context in order to receive the desired results.
Welcome everyone to the AI podcast. Today, our guest is Eugene from Endeavor,
Yeah.
and today we are going to talk about large language models. Especially, Eugene will show us some examples of GPT-3 and ChatGPT and how prompt engineering works, which is an important aspect of using large language models. So, without further ado, Eugene, please take it away.
Yeah, thank you. So my name is Eugene. I work at Endava as a data analyst, and I was lucky enough that 1 year and a half ago I've got in a project uh, where I get my first touch with GPT-3 as a large language model, and for the last 15 months I did with my team we did a lot of research, and most of the research was focused on how you make those language models produce the output you desire, because they are generative models. So basically they generate the next token, the next output. But in order to solve some complex equations or some complex tasks, you want them to funnel them in a specific way and receive some desired outputs. So this is when we start searching for papers, recommendations regarding prompt engineering. Prompt engineering basically is the way you interrogate the model, providing him some context in order to receive the desired results. So long story short, I will tell you today what was our latest conclusion. So what we came to, and then I'm going to demo some examples of how your prompt defines the output. Okay,
Perfect.
so if you let me just share my first. I prepared a presentation, and then we're gonna go to ChatGPT for examples.
Brilliant.
Let me see if I can share this, and I think I can share this one. Okay, so basically, do you see my screen?
Yeah.
Okay, so what we have here is some recommendations, including from the guys from the OpenAIs, and from some papers that we research of what you should do to write a quality-wise prompt. Okay. Um, so the first couple of things is um, I still remember reading a lot of scientific papers and blogs and things like that. And
Yeah.
one that stuck to my mind was that when you talk to a large language model, uh, try to imagine that this is a 10 to 12 years old kid. So basically, it has the capacity and potential to perform even complex tasks, but you have to give it a lot of context. So the more context and the clearer you explain to him, the better would be your output. So that was one of the main things that stuck to my mind. And one of the most important um, recommendation is that you have to show, not just tell. So um, I, I'm not sure how many of you are familiar with the prompt technique. So basically, we have zero prompt technique. It's when you just ask him to do something without no context. So, like, for example, you say, I don't know, write me a list of best ideas for a blog, for example.
Yeah.
Second, which performs even better, is one-shot prompt technique, which you provide one example. So basically, give some context. For example, you give him, here's the list. Here's the top three. I don't know, songs that describe for summer, for example. And
Yeah.
then you ask him, can you write me next 10, for example? So basically, the model will analyze the context you give, and then we'll try to stick in those formats that you gave.
That
And
is
the most,
interesting because you are sort of taking the word from how we use other sort of deep learning model. Like if it's zero shot, then you don't give it no example at all. Just ask it to perform a task. And one shot is giving one example. And then it's like more than one is like
yeah,
giving multiple examples and
exactly.
asking it to generate uh, some text based on
Yes.
multiple examples. Okay, that's interesting.
Yeah. So basically, the more examples you give him, the better performance you'll receive, because it now has context, it now has a
Mm,
formula and the syntax to follow. So basically, you help the language model to extract the knowledge you desire.
okay.
Um, I will not go through all of them, but most important of them is this. So basically, you have to show, not just tell, and try to use plain language. When I interact with BERT or GPT models, I always try to talk to him like I would talk to a peer. So I always say like, please
Yeah.
do that, uh, generate that, compile a list. So basically,
Mm,
I'm trying to use plain language, but be descriptive as much as possible. Okay. Showing the
awesome.
model how to respond is part of the few shot prompting. So basically, when you give some examples, the best way is not just give examples, but you give him an example of a question and an example of an answer. For example, I don't know, extract keywords from this sentence, and you give him a sentence, and then the example would be keywords, and you mention them. Uh, by providing that, you will you'll make the model know exactly what keywords you value most. So he will try to extract these types of keywords. For example, if you extract more names and emails, you'll know that that's what you want. If you extract only nouns and verbs, so maybe this is what you want. So he'll try to stick to a formula.
Mm,
Okay. Um, so these three: show and tell, provide quality data. And there was another recommendation, which is a more technical one, is like check your settings, because there are two very important parameters of a language model. One is temperature and another is top P. Um, at the beginning, I was wrongly thinking that temperature is the parameter that controls the freedom or the imagination of the model. But in fact, it was a much simpler thing. So basically, when you give the highest temperature to the model, each time when you prompt it with the same exact prompt, you will
mm,
receive slightly different results. So basically, it's a variation of results,
mm.
but the core of the generated text will be the same. It will
Okay.
just use different words to describe the same thing. And
Mm,
but if you want, let's say you do some programmatic commands, extract some commands. So you want every time you prompt to this prompt, you want the same result. So in these cases, it is recommended to go with a zero temperature, and you just raise the top P. The top P is the opposite of temperature. So when you raise one, you lower the other, and vice versa. So they
okay.
okay. Let's keep that not important. Yeah, it's very important to offer hints and tricks. Yeah, if you have, of course, if you I don't know, if you want to generate a blog article, or let's say a marketing document, something like that. So basically, you'll want to be very specific, provide a lot of details, and provide some hints and tricks that is specific to your domain, uh, because large language models are very capable of going down to your domain specific language. But to do that, you have to make them understand that you want to use that language. So it's very nice if you uh, we even played with some scenarios like we put the context like, imagine that you are now Snoop Dogg, for example. I'll ask you questions, and I'll ask you serious questions, but you try and answer me in a pure Snoop Dogg style. And it did just that. After a couple of
Perfect.
changing the prompt we received. So basically, it was responding to very serious like environmental question, but in the Snoop Dogg style. So it was genuine. We're very, very impressed by that. So that's what you can achieve if you provide it with quality text. You use plain natural language. You don't have to respect grammar because GPT-3 is very capable of ignoring your mistakes, except if you do more mistakes than proper words,
Right.
then GPT-3 or any other language model, it will assume that that's the way you want your answers to be, and it will switch to wrong text. We experimented with that. So if you do that, it will take the biggest part of your text, and if there are more mistakes than correct words, it will switch to that language. But otherwise, if you do mistakes here and there, it will ignore them like they would never happen. Okay, so without further ado, let's switch. Let me switch to the second screen, share, and let's go through some examples.
Sure.
Okay, so what I'm going to demonstrate here is some prompt engineering techniques. Let me just load it. The context was clear. So like this, we wanted to make GPT-3. I used then GPT chat, but I did the same exact exercise in GPT-3 Playground. So what I want to receive a list of actions that I can transform in some programmatic language in executable actions from a user input. So I started very vague. I said, okay, let me see. So I said, okay, let's generate a list of actions that I should perform in order to order food online. So the ChatGPT gave me 11 steps, but as you can see, it's a lot of text, and that's not what I desire. So then I changed my prompt to this. I said, okay, please only generate very short answers, avoiding useless noise. So I left the first part of my prompt and then added some more context. And as you can see, the results there now was very short. So basically, he cut them to the core. But this is not what I needed still. So then I said this: transform each action into some executable short commands where each verb is put between parentheses and the noun is prefixed. And I gave him one example. So this is already a one-shot technique. So I said, this is an example you should use, but this is a syntax. I gave it one shot of syntax. I never gave it like an action here. So what he did, he took the previous list and embedded it in the syntax I gave it. So he used my key to put the verb in parentheses, and he tried to put the hashtag before every subject, but as you can see, it failed on a couple of occasions. So I needed more help. And as you can see, by doing prompt engineering,
can you increase the font a little bit, the size of the?
Yes, let me see if I can do it like, no, not like this. Let me see, 1, 2, okay.
There you go. Yeah, much better.
One cons of doing this is that you increase your tokens capacity. So basically, you use more tokens to describe a problem that maybe you could do in a better way. But this is always the first step. So first time you try to funnel it down to your desired result, and then you try to find a shorter prompt that will do the same. And I'll show you how you can do that using GPT language model. Okay, so we took that, and then I said, okay, now please remove your, because I saw a lot of your here from the generated text, and make it even shorter, like parentheses and subject. And this is what I received. So basically, I receive a verb and an action on some object, for example.
Right.
Again, I needed to make it even more programmatic wise. So what I do here is I ask him to assign all those commands to a Python list. So it does exactly that. It generates me all the variables using the key I provided and creates a list, a Python command that will contain all these commands.
Yeah.
Now I said, please use only lowercase and remove all the dots because I saw a lot of dots here. Okay, so I fine-tuned that. I receive only lower cases, no dots. Now I can, this is a list that I can iterate through if I need it.
Yeah.
Okay. Now look what I did here. Now this is the proper one-shot technique. So basically I take this generated list and I insert it as an example here. I said, okay, I needed to generate a list of short programmatic commands that represent a step-by-step flow of an action. And I give it first action is order food online. And this is the list of actions. It's the one that it was generating before. And then I said, now I need the action change a flat tire. And I put the keyword list of actions and I wait for the model to generate it. So as you can see, now I removed all this big text that I used to get to my command. And
yeah.
I provided the result because I now can use the same number of tokens, but I can receive another list that
Yeah.
I want to receive in the end. So basically what it does, it uses the first list and replaces it with the actions for changing a flat tire. Okay.
Yeah.
Now what I do, then I did two more actions like that. I generated one for making a coffee and one for making tea. So now I use the few shot technique. So I give it 3 examples, even 4. And again, I said now generate a list for changing a flat tire. Why I
Interesting.
did that? Why I did that is because I saw that it was quite biased on the first list. So the model was trying to replicate the first list very strongly, and sometimes it gave me, for example, it gave me here the command park the vehicle or turn on the hazard light. So it gave me some commands that I did not want them to be in my command. So I thought, let
Gotcha.
me give him more example and see if it changes the behavior. It did not though, just a bit, but what it did, it followed very nicely the syntax.
Right.
And I thought then, okay, I can work with that. What I did here now, I said, okay, ignore all the other words. So let's make the commands as short as possible. So avoid noise and only generate verbs and nouns because that are mandatory for the command. I don't want any other text to be generated. So it did just that. It removed everything which
Right.
it thought is not the basic. So you cannot now you can see that you don't have here park the car, put the hazard light. So you have the core of the actions. And that I thought, okay, that I can use. That looks nice. In a programmatic way, you can always iterate through those and using a regex to extract key and values and replace them for everything else.
Yeah.
But then I said, okay, still some of the actions are not linked between them in a very logic way. Some, for example, I like here, for example, to log some nuts, you need first to get the tools necessary. Without those tools, you will not be able to change the tire. So what I said here now is, let's generate a more accurate prompt that will instruct. Oh no, this is not. We're another step. Sorry, my bad. What I did here is device prompt engineering. Now I'm trying
Right.
to ask the model to generate me the prompt that will lead to that exact result. I said, okay, generate the most
Okay.
accurate prompt that will instruct a large language model to return the completion without providing any of the steps from the flow. So I wanted to see if I can have a very short prompt that can lead to those results so that I can avoid all the text before. And it provided me with this. I just copy pasted it here and I saw that it generated the list, exactly the list above. Okay. And here is where I said, okay, one more request. please write that list in Python code. Put each step starting with a new line and add a comment at each step line where you explain how this particular step is logical successor of the previous step and the predecessor of the next step. I just wanted to see if the model understands what is the flow to get from action one to last action and if they are logically connected. So
Right.
basically, this is what it does here. It tells me this is called the chain of thought. So basically, you ask the model to reason why it did generate that and that.
Yeah.
Okay. And when I was reading that, I saw that it grouped some actions between them in some groups. And the last thing that I wanted to add is, okay, I said, now I need the tools. I need to add here the tools, and I think my list is perfect. So what I said here, we need to add more details to the action list. For example, there are missing intermediate actions between the actions. Like, for example, before these actions, you need first to get the necessary tools. Same for jack the vehicle. You cannot jack it if you don't have the tools. So ChatGPT updated my list, and you can see now we have a lot of great details. We have open trunk, remove tire, and this is grouped under get necessary tools. Then you have the second group when you start to loosen the lug nuts, and then is another group where you jack up the vehicle. So I thought this is very, very nice. One disclaimer that I have to do here is that when I tried the reverse engineering, this one, no, this one.
Generate a command.
Yeah, it might not work if I'll start now a new chat, because right now in the difference between ChatGPT and GPT-3 is that chat has context. So everything we said above is remembered.
Yeah.
Every time I prompt it again here, everything which is in this conversation is part of that conversation. So it uses it at context. So for example, if I'll go now to a new chat and try, I just want a new chat. Okay, let me see this. Let me do that. And if I do that, I'm not sure if I'll receive the same result because now it doesn't have any context. So
I don't think you will get the same result. ChatGPT does remember the previous results.
Yeah, exactly. So that's important. That this is also a very important point for prompt engineering. So so basically, if I want now to receive the same result, I'll have to give it at least one example. I need to provide context. When we do it programmatically, you can call the playground. You have the API that you can call and simulate the playground. So one suggestion would be when you do it programmatically, always think about a mechanism that will infuse every prompt with a context. So we try to save the context in a separate variable, and every time we prompt it again, we provide the context. Sometimes it's hard because you have a lot of tokens to use, and what to do here, we take all the context. For example, if the context is more than 500 tokens, we take all the context, go to another GPT-3 instance, ask it to summarize, and then go back and use the summarization, which is much smaller, as a context, so that you always try to keep him between your expected results. I think that's it for the demo. So if you have any questions right now or other topics, because we can discuss about it like forever.
Sure. Perfect. Do you want to stop sharing?
Yes. Let me stop share here. Perfect.
Awesome. Yeah. Thanks for the demo. I have a lot of questions. I mean, I've been playing with ChatGPT for quite a while now. And now we have GPT-4. So I've recently started playing with that a little bit as well. So there was an article recently about some researchers are looking into why ChatGPT can perform some tasks so well, even even though it hasn't been designed to perform those tasks. For example, the bar exam, the Olympiads, and other exams, which it does pretty well, even though the topic of these exams are completely different. One is science, one is law, and you can perform other tasks, writing codes and everything, which are completely different tasks. So they came up with two assumptions. One is either it is really good in understanding statistics, because after all, a language model is just a statistical model. Or it's doing something new that is something we have never seen before, which is something happens inside a large language model when you train on billions and billions of parameters, and then you give it a ton of examples. Something new happens. So what do you think we at this point with your experiments, which way do you bias towards?
When we started with GPT-3, there was this text Da Vinci 002 model. It has this limitation. So basically, all our research ended up in the conclusion that you cannot do complex math with that. It is good with a very simple math that you cannot do complex math even though you provide context, more information, examples. So it was failing at that, and the understanding was that it is a language model. So basically, its main task was to predict the next token, next word. But as you said, during the training, this language model gained some hidden capabilities that then became obvious. For example, you could do in the same playground. You can do text classification, summarization, named entity extraction. All you have to do is just post these questions. For example, you would not switch anything. You would not touch any parameters. You would just say, okay, I now want to extract parameters from this text. Now I want to classify it, So basically it was capable to do it like seamlessly, to switch between tasks. And those were only some examples provided by OpenAI. But then we found out that it can do even more. So yeah, it has some hidden capabilities that at that time when they launched, they were very raw and green. And then came GPT 3.5 with this text Da Vinci 003 model, which overnight became very capable. So basically all our experiments that we were doing on the previous model improved drastically with the new one. And now we could use less tokens, less context, and we would receive the same results as before with more tokens. So it was clear that OpenAI started to extract those capabilities, those hidden capabilities from their model. And what we are now seeing with GPT-4 that can now seamlessly read images and reason on any image. So basically, you can ask what's in an image, and it will describe it. So basically, it again shows that, during the training, seeing those billions of training data, it deviates from its main purpose, which was the generating text. And now they are capable to do things that we could not imagine a couple of years ago. The only thing is that we have to find the right way to ask it to do it. So what I like about ChatGPT and GPT-4 is that now, besides the playground, you have this system box where you give context. So basically, you have a separate field where you give context, and then you have the field that you prompted, and the context will always be there. So it is your org. Now you don't have to use the same prompt, because right now we were structuring like, let's use initial prompt at the beginning and then add our questions. It was quite complicated. Now with this new tool, you basically have the context. You can always fine tune the context when during the course of action you see that it goes in a direction you don't want to know, and you go back to context and say, oh, okay, let's add this here or that here, or let's change that.
Yeah.
And it helps. So yeah, I think it's still far away from doing everything at the highest quality, but the progress, at least in the last 2 years, is fantastic. So now I saw a paper that we have chain of thoughts, and then we have, I forgot, have chain of. So basically, this paper says that if you prompt the model in steps, so basically, first time you give him a question, you receive a reason, then you reason it. For example, you ask why 2 plus 2 is 4. So it will, you tell him 2 plus 2 is 4 because, and you provided the reason, and then you prompted 2 plus 3, and it will now provide the result, because you told him that don't give me just result, give me the process. And this is one of the ways you can reason with the model, but there are a lot of many papers that describe different prompt engineering techniques that can lead you to the desired results, even in the field of math, where GPT-3 was quite kind of weak.
Yeah, regarding that was my one of my questions for later, but I'm going to ask it now. Like, did you experiment with simple math problems? So far, the results from the ChatGPT has been pretty bad in my experience. Like, it cannot perform simple math problems pretty well. But can it be done properly? Like you gave an example of if you do cross reasoning with simple math problems, as in why 2 plus 2 is 4, and can it improve it answers?
We only tried a couple of times at the beginning, and we stopped there because that was not our scope of the project. So our scope was to extract from natural language
Gotcha.
a list of actions that you can execute in an IT background. For example, let's say you have a program that you developed, and you want the user to write or talk to you, and you transform that in some. For example, you said, I need to go to Eugene's page in, I don't know, in Java internal application. So you want to extract key elements, not find the steps, and just execute the action. So this is what we try to do for the last couple of 15 months or so. And because of that, we did not pay much attention to other, let's say, cons of the GPT-3. We only took seriously the thing that GPT-3 and even other language models, like we used BERT and Roberta a couple of times, you cannot be sure 100% in what they output. So everything they output, you should take it with a pinch of salt. So you always have to double check, because there is this hallucination phenomenon. So when the model doesn't know the result, it will invent something. And as a solution, what we did is that we always restrict it in the way that we say, okay, this is what you have to do. We try to provide it with a list of actions. We have it, and we say, like, if you cannot find any reasonable actions from this list, just return unknown or return I don't know. So all our prompts are restricted with this final phrase that please don't invent anything new. Just stick to what we have. This way, we try to minimize the misleading information, because sometimes, at least at the beginning of the project, we received a lot of output that you could not check it on the spot. Is it like that, or is it true, or is it the models inventions?
100%. And I think that's a big problem if you're trying to use it in the industrial application.
Yes,
That
yes,
is a
exactly.
big problem. Another thing is the corpus that was used to train ChatGPT was probably limited to the year 2021, I
Yeah,
guess.
yeah, yeah,
And
exactly.
that is another problem because if you try to explain any algorithm or anything that was invented after 2021,
Yeah,
let's say in last year, last 1 year or last couple of months, it will invent some new ideas that is completely false.
yeah,
For
yeah, exactly.
example, I gave it I tried a prompt to explain stable diffusion to me,
Hmm.
and it basically explained how stable diffusion is just a generative adversarial network, which it's not.
Yes, exactly.
It's their principles are completely different. So uh, that is something another problem. I'm not
Yeah,
sure how to circumvent that though. Do you think it's possible to? How do you circumvent that? Like all its
yeah.
data comes from 20 before 2021. So
I see here two solutions. One of them was that, for example, you can use this context field and provide this new information. So you have to
mm,
find it, copy paste it, and provide it here, and say that, okay, on the subject we are now in, pay attention. There is a new development. So you
yeah.
provide the information. And the second one is the possibility, you have the possibility to fine tune any of the models. And
Mm,
we experimented with fine tuning. So basically, you prepare a CSV file with prompt completions, and you can make it tailored for your specific domain. For example, um, we use this list to commands. So basically, we provided thousands of user inputs and how you extract from them commands. Um, and while we were doing the fine tuning, we also find out that this was one of the tools that you can use to provide the model with more information. For example, you want something new that it was not trained on, so you can provide it. But there was a little cons in that thing, is that the outputted model was very biased on the information you provided, and
mm,
we could not find a way to circumvent that, because it was uh, it, the information you provided. You should be very careful with what you put in this fine-tune file, because after that, the model, even the best of them, even the Da Vinci model, was every second time he would try to respond it with some information from the file, and not do the work you were expecting him to do. So it's like it is a solution, but it's still not final. It's still not optimal. So even if you use the system context window, again, how many pages of text you can put there?
yeah.
It's okay if you only want to put the information about stable diffusion, but what if you want to insert every new research just from 2021
Yeah.
to modern day? So um, it's still not optimal. Yeah, but I think we'll get to that. I think that they'll have a solution where we could um, a mechanism that you could use to let's say update the weights of the models with new information. I saw a guy on Reddit, I think, that uh, after half a day he convinced ChatGPT that Darth Vader is the president of the United States. So
Uh-huh.
it took him a while to provide this new information, but after hundreds and hundreds of prompts, after that model was convinced that Biden, I think it was Trump there. So it was convinced that now that Vader is the new president of the United States. So he said that you can do it with a lot of prompts, but it's again you have to wait the price and the how much you need that.
Yeah.
You're ready to pay the price for thousands of tokens
Mm.
to input just a new line of information into the model.
So he sort of fine-tuned the model to believing that Darth Vader is the president of the United States.
Yeah, but it only worked like uh, in that day, and next day when he logged in and started a new chat, it was back to the basics again. So it's still tricky. So I think it's linked to your session ID. So somehow, so basically for a day you can make ChatGPT learn what information you want to give, but then I think it has a mechanism to reset to the default. So
Interesting. And are you guys using the API calls from OpenAPI to log in through your own portal and writing codes in Python and that kind of stuff?
Yeah. On the company side, we have a key, a project key,
Yeah.
and we use all these keys. So basically, all our calls are grouped under the same collections of calls. So they somehow connected.
Can you speak a little bit more on how to fine-tune a model? Since you have experience with fine-tuning the model, I haven't tried it before. I'm definitely going to try that. What is the process of fine-tuning looks like?
So basically, you have to prepare the CSV file. It should contain just two columns. It's prompt and completion. So prompt is the user inputs, and completion is your expected results. And you have to to provide it a lot of rows. So we experimented with 200, and then 600 to 1,000 until 2,500 lines to see which is the optimal. So, and somehow our test, the accuracy was quite high at 1,500 prompts. And after that, it was racing very, very slightly. So we decided to stop there as an optimal size, because it costs you to fine tune a model. It costs less than to prompt it, but then when you want to prompt the fine tuned model, it's double. It's doubled? Oh, no, it's 10 times more expensive than the regular model. So it's still a backlash. So basically, what you do, you have this file. You use the API to upload it to OpenAI cloud, and then you receive a file ID, and then you use this file ID, and start the process of fine tuning. Basically, it's like 25-30 minutes, around like this, and then you receive back the successful responses that you have fine tuned the model, and you receive a model ID. And all you have to do now is just, when you call your model, just replace the standard model name, like it was Text Da Vinci. You replace it with this new model ID that you received, and it will now always query that model.
Gotcha. Okay. Yeah, I'm definitely gonna try that.
That was the process, and I think there was an expiration. But if you would not use that model for, I'm not sure, I think it was 90 days, something like that, it would be automatically something like that.
Interesting. Okay. Have you guys tried any other large language model from other companies? For example, recently Meta came up with Llama, and then we have other language models that have been popping up everywhere. Of course, Google came up with Bird, which kind of failed, but I mean, it did pretty good. It failed in the industrial application, but still a good language model. And then you have some other language models popping up from Stanford as well. Have you guys played around with those yet?
We tried a couple of them. What we tried at the beginning was this GPT-J and GPT Neo X.
Yeah.
Those two, and then we tried. We used Bert and Roberta for semantic search, because we also evaluated the semantic search functionality. We wanted to see if maybe, instead of prompting the model with an user input and getting a list of actions, maybe we could prompt the model with a question and search a knowledge base for results. So maybe we don't need the list of steps. Maybe we need to provide him, let's say, a document, or an FAQ document of how to do something. So
Yeah.
At one moment in time, we experimented with semantic search and we used BERT semantic search, and also they embedded in GPT-3 semantic search functionality. They have a special API.
Yeah.
It's /search, and it does the embeddings and then the search. So both performed pretty well, and because BERT was free, so basically you can stick with BERT. But regarding the Neo J and Neo GPT-J and GPT Neo X, we tried them in generating these lists of actions, and they were quite far away from the most powerful GPT model. For example, they were okay against Curie and Ada models, but Text DaVinci was always above. So basically, DaVinci was always around 75, 80% accuracy amount text samples, and the others were like under 40 even. So I think it was on the third month of the project where we decided we will go only with GPT-3, specifically because it was very easy to switch from one task to another.
Yeah.
You would not have to use different API. You just form a prompt and it will do the task you need. And it was very accurate.
Yeah.
So
I think DaVinci was the first large language model to pass the bar exam, and that was a monumental sort of task to overcome. So that was a milestone in large language model world, for sure.
Yeah. And on the few shot prompting technique, it was benchmark at the moment. So 1 year ago, when we tried, when we did some benchmark research, it was better than Google and other languages that we tried there. So because we know that the zero shot technique is the desired one. You will always want to expect to expend as little tokens as possible, but if you cannot receive the results with zero shot, it's always this possibility you go to one shot on few shot technique, and the results are always guaranteed to be better. So that's we kind of stick with that.
Interesting. Another question is recently a journal, a blog post came out from I think it was from Washington Post or probably New York Times, and the author sort of went into describing how this large language model works, because now it is embedded in Bing, which is a search engine. So instead of connecting directly into the internet, now you have a sort of a knowledge base, which is which has the data from everything we know about everything, all the documented information we have in the humanity since we started digitizing data. And the author sort of compared ChatGPT with JPEG compression, as in a JPEG you have the information of an image, but it's so heavily compressed that you have like some information that you can extract, but you cannot figure out many of the stuff that has been compressed too heavily. And he goes on to saying that ChatGPT is a bad compression of the human knowledge, and it sounded a little bit poetic to me. Do you agree that ChatGPT is like a bad compression of human knowledge, or maybe it's a little bit more than that with a little bit of guidance?
I kind of agree. I kind of agree because the expectations are quite high. With such a large amount of information, it is clear that potential is still not realized. So we are still quite far away from the true potential. So I kind of agree with you because the information is there, but the way you extract it, and mostly you are limited by two factors: your imagination and what the API offers you as a tool to extract. So I think there is still room to leverage all this, and you can extract more. But yeah, sometimes we had in the project situation when you tried all the stuff, and you still don't get the result, so you're like, oh, come on, I know you can do that, but how? The question is always how. And it's not always the user part, like the prompting techniques. Sometimes there are still limitations from the system. So I also looking forward to this GPT-4 to see how the combination of text and visuals
Yeah.
can help to level up um, information's extraction. So kind of answering to your question, kind of agree that it's still
100%.
not optimal. Mhm.
Yeah. All right. Yeah, that's all the questions I have at this point. Do you want to share your parting thoughts before we end the podcast?
Oh, so thank you for calling me. It's my first experience of this kind. Um, um, what can I say? The future looks very bright. So I'm still following all these papers. Uh, Even yesterday, I was reading about Cosmos of Microsoft Cosmos. So it's very impressive. So I think it's a trailer for what GPT-4 will be capable of, because they have some connections with OpenAI.
Yeah.
So yeah, I think large language models. Uh, I'm not sure it's the future, but it's the present. It's for sure. And uh, we as humans not only have access to information one click away. So basically, all you have to do is to do a proper search to receive all the information you have. Now you have the tools to use that information and uh, to extract yeah, things like more utility things, more you can transform it in knowledge, you can transform it uh, in usage. So yeah, I'm quite impressed. I have, like I said, 15 months in this project, and I'm still discovering every day things that you can do with that and that. Um, for example, even these days we are trying to do the reverse prompt engineering. So what if we tell the model to do the things we want to do? Let's do it the vice versa. Let's do it.
Mm.
Hey, can you please write me, I don't know, a prompt that will extract me these actions, and you give it the actions. So we always try to change the way we do things, to see if that can help us extract even more knowledge from this model. That knowledge that somehow I believe is still hidden there.
Mm. Interesting. So you're saying that probably there is more we can do to extract the knowledge that's sort of hiding inside
Yeah,
ChatGPT.
yeah, yeah,
Interesting.
exactly.
Awesome. With that, I'm going to end the podcast here. To everyone, if you liked our podcast today, please like, share, and turn on the notification bell to the YouTube channel. And thank you, Eugene, for joining our podcast. And I'll see you on the
Thank you.
next episode. Thank you
Yeah,
so
thank you
much.
for inviting me. Thank you. Good luck.
Thank you.